So now I want to look at the multiplication rule, and we're going to need that conditional probability to work with the multiplication rule. So to do this, we're going to go back to our cars again. There's a blue Toyota, blue Ford, green Ford, green Mercedes, and another green Mercedes. So we might ask this question. This is our sample space here. Let's say we want to know the probability of Toyota and blue. Now, we want to be careful here. We talked about the probability of Toyota or blue. What that means is if we pick a Toyota or we pick a blue car, we win. So we can win with the Toyotas, we can win with the blue car that's not a Toyota. And so the probability of Toyota or blue, either one will win. Well, here's a couple Toyotas, and then we can also win with this one because it's blue, the blue Ford. So 3 of these elements out of the 6, will work. So that's what we've got. So 3 of these out of the 6 will work. So what about Toyota and blue? Let me put this down here. Well, this means it has to be both. Has to be Toyota and it also has to be blue. Where there's only 2 things that do that. That's going to be 2 out of 6. So when you have that, well, I mean, that's what we do. So now there's a trick here. First off, I want to talk a little bit about and. And equals what's called an intersection. And is an intersection. So what's going on here is we're looking at where 2 events are overlapping. So for example, here's the event that we have a Toyota. And this would be an event that we have a blue car. So what elements are common to the event of blue car and the event of Toyota? Well, only, blue Toyotas. So that means the event of Toyota, and we use this special symbol. It's like an upside down cup. That means intersection. In blue, well, it's only those elements that are blue and Toyota, and there's a couple of those. And that's it. So that's what we mean by our intersection. So and I'm being really loose with set notation here, by the way, because I usually don't have repeated elements in sets. But anyway, so those are the 2 elements that are Toyota and blue. So what we do here, let me give you another example of this idea. Let's go back to, let's say, our A and B. It's a little bigger. So here's A, here's B, And let's put some numbers in here. 1, 2, 3, 4, 5, 6, 7, 8. When we talk about the intersection of A and B, what we mean are only those elements that are both in A and in B. So that'd be 4 and 5. And we might talk about, well, the union, for example, would be all these together, the union of A and B. That's where we dump everything into the same set. So now I'm going to use proper set notation. So when you take the union, you just combine everything together. Take the intersection, you only work with the overlap. All right. So going back to our car example, we saw this, that the probability of a car that's both Toyota and blue at the same time was 2 out of 6. Excuse me. So let me make a note. And let me put our sample space up here again. I mean, if you have it in your notes, you can just look at it in your notes, but I'm just going to write it up here so we can follow along a little better, hopefully. So Toyota and blue. There's only 2 that are both Toyota and blue. So I'm going to make a note. The probability of blue, let's see here. What's the probability of just getting a blue car? There's 1, 2, 3 blue cars. That's 3 out of 6. It reduces to 1/2, but we'll keep it this way just for simplicity. Also note, though, the probability of getting a Toyota, given we've reduced our sample space to just blue cars. So if we do that, well, the sample space, if we reduce it to blue cars, there's only 3 blue cars. So that's what this part says. Then we go to this part, and it says, well, how many of those are Toyotas? Well, there's 3 blue cars, 2 of them are Toyotas, so 2 out of 3. All right. So this is what we're going to do. This here, it reduces the 1/3. We can rewrite this 1/3 is the same as 3/6 times 2/3. You're going to get the same thing. Or put another way, the probability of Toyota and blue is equal to the probability of blue, which was 3/6, times the probability of Toyota given blue. Because this is the probability of blue, that's the probability of Toyota given blue. This is actually a general formula. The probability of A and B will be the probability of A times the probability of B given A. And so that's a general formula that we can use. All right. So that's it. If you have any questions, let me know.